in this video, we are going to discuss how to solve problem using position versus time graph. So position versus time graph is a graph that has position on the y-axis and time on the x-axis. That means your independent variable will be time and dependent variable will be position. And this graph is basically used to determine the position of an object at a given instant or to find its distance and displacement. So let's look at the question here. When did the runner whose motion described in figure 11 reach 12 meters beyond the starting point? Where was she after 4.5 seconds? Now, whenever the question used the word when or how long, both of this word means they are asking you to find time. So look at the keyword when and how long. If you find this in a question, that means the question is asking you to find time. So in the first part, they want us to find the time at which the runner reached 12 meter. So we will find on the graph where is 12 meter. 12 meter is the value of position. Position is on y-axis. So we locate 12 approximately over here. And then we go to the graph. Wherever we reach the graph, we find the time value there. So this is the point, or this is the time at which we reached 12 meter. This point is exactly between 2 and 3, so it will be 2.5 seconds. So I can say we reached 12 meter at time t equals 2.5 seconds. Then in the next part, question is asking you where was she after 4.5 seconds? Where means they are asking you to find position. Anytime question says where, you must find position. So where was she at 4.5 seconds means I need to find her position at 4.5 seconds. So locate 4.5 seconds on the graph. It has to be between 4 and 5 over here. Time is on x-axis, so I will locate it on x-axis. Then move up on the graph, move up on the line. Whenever you reach the line, go to the y-axis, go find its value on y-axis. So this value lies between 20 and 25. So it is exactly in between or midway between these two values. So I can write my position value to be half of these two. So 25 plus 20 by 2, which is equal to 22.5 meter. Now, how do we find a point exactly in between two numbers? You find the mean of the two numbers. How do you find the mean? You add the two numbers and divide them by 2. This is how you can find the midpoint. And if you're still confused to find the midpoint, you can just approximate the value. You can take this as 22 or 23. Next question. The graph in figure 13 represents motion of a car moving along a straight highway. Describe in words the car's motion. So if you look at position time graph, it is going down like this. And a graph going like this means it is moving towards origin. So in order to describe this, I can say that the car started at a point here. We will find the value of this point. Again, it lies in between two numbers. And like I told you, you can calculate in between or the midpoint as x equals, add the two number 150 plus 100 over 2. That will give me 125. So the car begins its motion at 125 meter. It moves towards the origin and reaches the origin at 5 seconds. And after that, it continues to go beyond origin with the same speed. So you can write your answer as the car starts at position 125 meter and moves towards origin. It reaches the origin in 5 seconds. After that, it moves beyond the origin. Then question 12. Answer the following question about car's motion. Assume positive x direction is east, negative x direction is west of the origin. So first question is asking us, at what time was the car positioned 25 meter east of the origin? Now positive x does not mean x-axis. X here represents position. So when they say positive x direction, this means positive values of position. So we need to find when was the car 25 meter east of origin. East means positive. So I need to find when was it 25 meter positive value. So 25 will be between 0 and 50. Now go to the graph. Wherever you reach the line, find the value of time there. So this value is between 3 and 5. So between 3 and 5 will be 4. So at time t equals 4 seconds, the car was 25 meters east of origin. Then in part B, they want you to find where was the car at time t equals 1 seconds. So like I said before, where means you need to find position. So I'm going to find the position of the car at time t equals 1 second. Locate time t equal 1 second. Time is on x-axis. This is 1. Then go up until you reach the graph. Wherever you touch the line, find the position value there. It's 100. So I will write x is equal to 100 meter when time t is 1 second. Then in part C, we need to find displacement of the car between time t 1 second and 3 seconds. Now displacement delta x is final position minus initial position. My final position will be at time t equals 3 seconds and initial position will be at time t equals 1 second. So let me find these values and then we can subtract them. So at t equal 1 second, we have already found the position value. This is the position at 1 second, which is 100 meter. So I will call this as x initial. Then we locate t equals 3 second right here. And we find its position. We go up on the graph. Wherever you reach the line, go to position. This is x final. Now we subtract them. X final is 50. X initial is 100. That gives me negative 50 meter. Negative sign means west because positive x direction is east. Negative x means west. So I can write my displacement delta x to be equal to 50 meter to the west. So next question 25. Look at the diagram and graph shown in figure 18. Do they describe the same motion? Explain. The time interval in the particle model diagram are 2 seconds. So here you have a position time graph and a particle model. And they are asking you if these two represent the same motion. So let us first write down the time values for our particle model and then we will compare. The time interval is 2 seconds. That means between each point, the time difference will be 2 seconds. So if I start at time t as 0, the second point will be at 2, third will be at 4, then you have 6, 8, 10, 12, 14 and so on. Now let's compare. When time t was 10 seconds, the position here was 10 meter. So in the particle model, at t equals 10 seconds, position x is 10 meter. So let's compare this with the graph. Let us find at what time were we at 10 meter. So we locate 10 meter, it will be somewhere around here. We find the time value at 10 meter. Time at 10 meter is between 2 and 3, which will be 2.5. So at time t equals 2.5, we were at 10 meter, which are not the same. The graph is obviously faster than the particle model. We are reaching 10 meter here faster than what we did in the particle model. So no, they don't represent the same motion. They are both motion along the positive x direction, but the motion on the graph is way faster than the motion on the particle model. So they are not the same. So you can write the answer as, in particle model, we reach position 10 meter in 10 seconds. In graph, we reach position 10 meter in 2.5 seconds. So they both travel in positive direction, but one is moving faster than the other. Next question. The graph to the right describes motion of two runners moving along a straight line path. The line represents motion labeled A and B. When and where does runner B pass runner A? So here the position time graph is for two different runners, A and B. And they are asking you when and where do this runner pass each other. So two runners will pass each other, or they will meet each other, or they will cross each other. These are the different keywords that they can use wherever the two lines intersect. Intersect means wherever the two lines meet or cross each other like this. So we need to find where and when. Where means position value, when means the time value. So when do these two runners meet each other? So look at the point where the lines cross each other and go to the time value there. The time here is 45 seconds. So when means time. So at t equals 45 seconds, they will meet each other. And at which position? So you can approximate the position. I'll take this value at around, since it is so close to 200, we can take it around 190 meter. And sometimes in the question, they can ask you how far apart A and B are at time t equals 0. How far apart means what is the distance between them at time t0. So I need to find this distance. So you can just subtract the two values. I can find the distance or delta x as 0 minus 50, which will be 50 meter. They are 50 meter apart from each other at time t equals 0.